Look at this parallelogram. A point sits somewhere inside it, and 4 straight segments connect that point to the 4 corners. The result is 4 triangles. 3 of their areas are known: 18, 31 and 24 square units. The 4th area is hidden. No side length is given. No angle is given. We do not even know the height of the parallelogram. So is the missing area actually determined, or could it change when the inside point moves? At first it seems impossible. A triangle's area depends on its base and its perpendicular height, and neither measurement appears in the puzzle. You might try to estimate lengths from the drawing, but that would be a trap. The picture does not need to be drawn to scale. The real information is not length. It is an area relationship that stays fixed while the point moves. Label the 4 triangles in order around the parallelogram. Put 18 in the first triangle, 31 in the second, 24 in the third, and call the 4th area X. The first and third triangles are opposite each other. So are the second and 4th. The hidden rule is that each opposite pair has the same total area. In fact, each pair always occupies exactly half of the parallelogram. Why? Focus first on the triangle along the bottom side and the triangle along the top side. Those 2 sides are parallel and equal in length. Call their common base B. Let the perpendicular distance from the inside point to the bottom side be h1 and the distance to the top side be h2. The bottom triangle has area 1/2 times b times h1. The top triangle has area 1/2 times b times h2. Now add those 2 areas. Their sum is 1/2 times b times the quantity h1 plus h2. Because the point lies between the 2 parallel sides, those 2 perpendicular distances add to the full height of the parallelogram. Call that full height h. The sum therefore becomes 1/2 times b times h. But b times h is the entire area of the parallelogram. So the 2 opposite triangles together equal 1/2 of the whole figure. The same reasoning works for the other pair of parallel sides. Their 2 triangle heights also add to the full perpendicular distance between those sides. That opposite pair must equal the other half. This is why the point can slide left, right, up or down without breaking the rule. One triangle may grow while its opposite partner shrinks, but their total remains fixed. The shapes change, the individual areas change. The opposite sums do not. Now return to the numbers. The first opposite pair has areas 18 and 24. Add them and their total is 42 square units. Therefore, the other opposite pair must also total 42. One of those areas is 31, so the missing area satisfies 31 plus x equals 42. Subtract 31 from both sides, and x equals 11 square units. We can also verify the result by adding all 4 regions. 18 plus 24 gives 42. 31 plus 11 also gives 42. Together they give a total parallelogram area of 84 square units, and each opposite pair is exactly half of that total. The answer is not 11 because the diagram looks balanced. It is 11 because parallel opposite sides create a fixed area invariant. This works for any point strictly inside a parallelogram when the point is connected to all 4 vertices. It should not be assumed for an arbitrary quadrilateral, where the opposite sides may not be parallel and the same height argument can fail. So the next time an area puzzle gives you almost no lengths, do not immediately search for a ruler. Search for something that cannot change. Here, the moving point hides the individual measurements, but the opposite triangle sums reveal the missing area exactly.